Hi, I am Pratiksha. Today my lecture topic is basic thermodynamics. So what is the meaning of that subject? The name itself is telling the meaning. Thermo means what, related to heat, and we know heat is the mode of energy, and dynamics means what anything is moving. So energy interaction is called thermodynamics. Basically the exact definition of thermodynamics is it is the branch of energy interaction and its effect on system and surroundings. So what are the key points here? System, surroundings and energy. So we know what is the definition of energy. This is very common thing. Now system, a fixed mass or region in space where our study is focused, is called the system. Let's here I am taking an example of hot cup of a tea. So now if I do the thermodynamic analysis of that cup, then that will be treated as system, and except the cup everything will be treated as surroundings, and the surroundings which will be affected or influenced by that hot cup of tea, that will be treated as immediate to the surroundings. Okay, surroundings, everything except the system is called surroundings. The part of the surroundings which is affected by the system is called immediate surroundings. Okay, now boundary, a real or imaginary surface that separates the system from surroundings is called boundary. The boundary can be fixed or movable. If I take an example of cylinder piston arrangement, so and suppose inside the cylinder gas is there. Now in that case, if I choose this is a system, so piston can move in to and fro motion. So piston, the boundary is not fixed here. So this is the example of an movable boundary. Okay, now types of system. Types of system. Three types of systems are there: closed, open, and isolated. I am starting from open system. So if I take an example of hot cup of a tea, then what will happen? The mass will be transferred from the top of the cup in the form of evaporation, and heat will also transfer from hot tea to surroundings. So in that case, mass is transferring and energy is also transferring in the form of heat. So this is the example of open system. Now closed system. If I put a plate on the top of the cup, then what will happen? Mass can't transfer in that case, but still energy will be transferred in the mode of in the mode of heat. So in that case, heat is transferring but mass can't transferring here. So this is the example of closed system. Now what is isolated system? In isolated system, mass and energy both can transfer. Suppose if I take an example of thermoflux, in that case what happen? Mass is fixed and energy, that means heat, can't transfer from inside to outside. So this is the example of isolated system. Now properties of the system. Properties are basically classified as intensive property or intrinsic property and extensive property and extrinsic property. So there are two classification of properties. Intensive or intrinsic properties are independent of mass. So how to remember which one is dependent and which one is not dependent on mass? So just see here, in starting letters are I and N, and I and N. So this is the tricky way to remember which one is dependent and which one is independent. So intensive and intrinsic properties are independent of mass, pressure, temperature, density, etc. The example of intrinsic property or intensive property. Suppose if I take an example here, suppose the volume of that cup is 50 ml and volume of this cup is 10 ml. Now if I pour the hot tea at same time in that cup and in that cup, the temperature will be same, though the mass is lesser in that case than that cup. So mass is but still what will happen? Temperature will be same but mass is not same here. So that's why the temperature is not dependent on mass. That's why temperature is an example of intensive property. But extensive or extrinsic properties are dependent on mass. What are the example? Internal energy, enthalpy, entropy, volume are the example of extrinsic property. In that case, mass is maximum, obviously, that's why volume is maximum. In that case, mass is less, that's why volume is also less. So that's why we can say volume is dependent on mass, and that's why the volume is an example of extensive property or extensive property. Okay, now important points on properties. Properties are exact differential point function independent of path history. What is the meaning of that? Here I am taking an example, or this is a cylinder piston arrangement. Suppose this is the initial position of the piston. At that state, at that position, pressure is P1. Okay, I am drawing this one. This is a cylinder piston arrangement. At state 1, pressure is P1, pressure volume is V1, temperature is T1. Suppose inside the cylinder gas is there. Now what happened? I have pushed the cylinder, a piston. So what will happen actually? The gas will be compressed. So at position 2, suppose pressure is P2, volume is V2 and temperature is T2. So at any position of the piston, we can measure the pressure, volume, temperature, density, everything. Every properties can be measured at any instant of the piston position. So all the properties are point function. At any instant we can measure these properties. Now what is exact differential? Exact differential means what? Suppose initial volume is V1 and final volume is V2. So what is the change of volume here? So we can write in that way dV equal to V2 minus V1. That's why this is the that's why we can say all the properties are exact differential. But if I tell what is the change of work done, then we can't write del dW equal to W2 minus W1. This is not right. We have to write in that way del W, or we can write del W, or we can write W12. So work done in that process means in that path. So this is a path function, or this is, that's why work done is an inexact differential. We can't write in that way, but all the properties we can measure, or we can measure the change directly by subtracting final minus initial. So all the properties are exact differential, and at any instant of the at any state we can measure the value of the properties. That's why they are the point function also. Now state of the system. Condition of the system is called the state of the system. So at position 1 of piston, the pressure, volume and temperature is this. At position 2 after compression, pressure, volume, temperature is P2, V2 and T2. So by choosing the properties, we can specify the condition of the system. This is the state. So this is the initial state and this is the final state of the system. Here you can see one thing, the system has changes its state here. So changes of state means what? A process. So what is process? The change of state is called process. Now types of process: reversible process and irreversible process. A process is said to be a irreversible process if when reversed in direction follows the same path as that of the forward path without leaving any change in the system as well as surroundings. Suppose in that example, if here I am drawing a graph between pressure versus volume graph. This one is the cylinder piston arrangement. At initial condition, volume is V1 and pressure is P1, suppose. Now after applying the force, suppose piston moves to that position, and in that position volume is V2 and pressure is P2. Obviously volume will decrease and pressure will increase. Suppose this is the position 2. So if I so 1 to 2 is a what initial state and the final state, but to change the state, the piston have to move so many state in between initial to final. So suppose the at some time the position of the piston is this. So in that position pressure is P3 and volume is V3. Suppose this is the state. So in that we can find, or we can plot the so many state in between 1 and 2. So after connecting all the state, what we will get a path, and this path, and this is the path, and this is called a process. So what is path actually? If I connect all the state from initial to final position, then we'll get the path, and the change of state is called a process. Now what is reversible process actually? So after applying the pressure, piston moves from 1 to 2. Now after releasing the force, if the system comes back to its original position by following the same path, then it will be treated as a reversible process. But actually it not happened. So many restrictions or losses are there, frictional losses are there. So the piston will not follow the same path if we release the pressure. So that's why it is not at that position, it will not be the example of reversible process. But if a system comes back to its original position by following the same path, that time it will be treated as the reversible process. And one important thing, all practical process are irreversible process. Okay. Now cycle, a system is said to have undergo a cycle when the initial and final points are same. Suppose after releasing the pressure, piston moves to its original position, then what will happen? Initial and final states are same in that case. So again after completing the cycle, what will happen? Volume will be V1, pressure will be P1. So in that case this will be treated as, or this will be the example of cycle. Initial point and final point, or initial state or final state, will be same for the cycle. So this video is very important for the beginners, and I will upload more video on thermodynamics. Stay with me. Thank you.